We used to believe that our world, our galaxy, was infinite and would never end. That idea was terminated at one point when scientists actually examined the universe and came up with theories and then evidence that confirmed that the universe, all matter, energy, and space, did at one point have a beginning and will at one point come to an end. Most scientists now believe that the universe started in a small, hot, dense state. This small, hot, dense state rapidly expanded, an eruption of light and energy that we have called the Big Bang. After the quick expansion of heat, the universe cooled down and created the stars and planets that make up our solar system. The Big Bang supposedly began the universe, our galaxy, and our world. It's intriguing that the Big Bang worked everything out almost perfectly. For example, if Earth were any closer to or further from the Sun in distance, it would create drastic changes to our planet and our way of life, if life was even possible. The 23.5 degree tilt in our planet is at the perfect angle for life to live year-round, and the reason that we have seasons. The speed that the Earth rotates is also very precise and important. It rotates once every 24 hours, what we call a day. Our day is 24 hours and our Earth is 360 degrees around. So every 15-degree rotation is an hour with the way that we describe time. Even the Moon and its distance from Earth has had an effect on our planet, and if it were non-existent, our world would struggle. It not only provides light for us so we're not in complete darkness, the Moon affects the water on Earth, the tides of our oceans in particular. It also affects the Earth's crust by heating it and causing the loss of energy, and stabilizes the axis of rotation of Earth. In order to observe our universe, the observable objects must also be measurable. Over the years, humans have come up with different ways to measure, like time, length, and mass. In our universe, everything is in motion. People are walking, balls are being thrown, cars are being driven down the highway. Even things that we don't see moving are moving. The Earth is revolving constantly around the Sun, stars are moving at very high speeds, and the Sun is revolving around the center of the galaxy. Motion is present in any change that matter goes through. Isaac Newton came up with 3 laws of motion that accurately explain how things move in our universe. His first law of motion states that an object will remain at rest or in uniform motion in a straight line unless acted on by an external unbalanced force. So, if there is no force acting on an object, that object will stay at a constant velocity. There are so many types of forces. Gravity, friction, buoyancy, and tension are just a few examples, ones that we see commonly in our world. Newton's second law of motion explains how an object's velocity changes when an external force acts on it. The equation F equals ma describes that change in velocity. His third law states that for every action there is an equal and opposite reaction. So when we're driving down the highway at 110 kilometers an hour and a butterfly hits the windshield, it's difficult to think that the butterfly had any impact on the car. Weirdly enough, the butterfly exerts the same amount of force on the car as the car did on the butterfly. The only difference is the car had no damage done to it that a car wash can't handle. Now, physics can explain everything going on in our world, even something as simple as the process of making a cup of tea. Heat is energy transferred from hot to cold objects, so the burner on a gas stove transfers heat to the tea kettle. The air around the kettle is warm due to radiation, the transfer of heat energy by electromagnetic waves. Temperature is a mass of hotness or coldness. Tea is usually too hot to drink after the water boils. It would be at least 100 degrees Celsius. Convection cooling helps make it bearable. As the tea sits, it cools off due to the circulation and movement of molecules. The spoon used to stir the tea gets hotter after being in the tea. This is an example of conduction, the flow of heat following physical contact. Because the spoon is metal, and metal is an excellent thermal conductor, it heats up very quickly through molecular collisions. Waves are all around us in life, even in places we wouldn't normally expect them. Skipping rocks is somewhere we would expect waves. When the rock makes a ripple in the water, a transverse wave, one where the particle motion and wave velocity are perpendicular to each other, is very easily seen. Where it might not be so obvious is in light and sound. Light is a transverse electromagnetic wave and color is light. Objects don't have color, they give off a light that appears to be a color, and different colors are determined by wave frequency. Sound can be transmitted as both a longitudinal wave and a transverse wave. The pitch of a sound is related to the frequency of the sound wave. The higher the frequency, the higher the pitch. The Doppler effect explains sound waves. Take a siren, for example. As a fire truck comes towards a person, the person will hear the siren get louder and louder. As the fire truck passes them, the loudness of the siren will then steadily decrease because the movement of the truck coming towards and then passing the person causes a shift in observed wave frequency. All of the matter that we observe is made of atoms, according to Dalton's atomic theory. Every time we breathe, we inhale atoms. When we drink, we are ingesting atoms. When we write, our pencil is made of atoms. Even our bodies are made up of them. Thanks to the evolution of the atom and the discoveries of the scientists, we now know that an atom has a nucleus, and that nucleus contains protons and neutrons, also called nucleons. Surrounding the nucleus are electrons, negatively charged particles that orbit the nucleus, as Bohr discovered. Protons are positively charged particles, and neutrons are particles that are neutral. We have been taught that like charges repel each other, yet protons and neutrons are obviously somehow held together in the atom's nucleus. What holds protons and neutrons together is quite an interesting force, the strong nuclear force. The strong nuclear force works only in a very short distance, less than 10 to the negative 14 meters, and it binds the protons and neutrons to each other. This force is the very thing holding everything in our world together at a nuclear level. Although everything in our world is made up of atoms, atoms are rarely by themselves. Almost everything we interact with and see are possible because of chemical bonds of the elements on the periodic table. These elements are like ingredients, and there are countless recipes to make up our world. Elements are found everywhere. We can find them in water, in our table salt, and in rocks and minerals. There are many reasons why geology is important in life and to civilization. Think about earthquakes, landslides, floods, droughts, volcanic activity, ocean water currents, types of soil, fuel oils, minerals like gold, silver, and uranium, to name a few. Many of Earth's natural disasters and much of the way Earth has formed has been explained through the help of geology. Through things like fossils and movement, we are able to discover what our world was like millions of years ago. We now know that we were once all one big landmass called Pangaea, and our countries came to be due to continental drift. It also explains how water can break rock, something that seems far from possible. Science affects us all every day of the year, from the moment we wake up all day long and through the night.